Very good afternoon, students. So welcome to IIT and NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 9 students of KTS Gudimalkapur, Varasiguda branch and Masterminds ECL branch so far. For today's session, as you can see on the screen and you are well aware, my subject is physics. We are in class 9th. Our ongoing chapter is kinematics. And today we are entering into the session number 2. So yesterday itself we started this chapter and we have given some introduction about what is kinematics, right? We discussed about what is kinematics, which is the part of mechanics. Then we have discussed about some terms related to motion. Very important point, because kinematics is nothing but study of motion, right? So study of motion without considering the cause is this. So when the body is in motion, we come across some terms, what we discussed in the last class. The one is physical quantity. What is physical quantity? We discussed about the quantity which can be measured. The quantity which can be measured is called physical quantities, which are divided into either fundamental physical quantities or derived physical quantities. Okay. The same physical quantities are further classified into again two. That is scalar quantities, vector quantities based on the magnitude and direction. Okay. Then after knowing about physical quantities, after knowing about fundamental quantities, after knowing about derived quantities, scalar quantities, vector quantities, we study about some more terms comes into play when body is in motion. Like, for example, we discussed about what is distance, what is displacement, right? So what is speed, what is velocity, then what is acceleration, and finally what is the deceleration or negative acceleration or retardation. It is also called retardation, anything. So these are the terms, of course, time. These are the important terms we'll come across when the body is in motion. Of course, time will come when body is in motion or rest also. So these are all the topics, all the terms we discussed in the last class of the synopsis 1. Today, we discuss what is the relationship. What is the relationship between distance, displacement, speed, velocity, acceleration, retardation, and time? Because why? What is the need means that relationship gives us the most important formulas in physics. That is equations of motion. The equations which shows the relationship between the distance, displacement, speed, velocity, acceleration, and time are called equations of motion, which are the basic formulas in physics given by Newton, right? So today we'll discuss about the equations and I'll show you the derivation also, how to derive that equations. You have to copy them neatly, right? You can find them in your material, but still I'll give a simple method to solve them, which are helpful for you in your regular syllabus also. So these are the topics what we discussed yesterday: physical quantities, fundamental, derived, scalar, vector. Then what is motion? What are the types of motions also we discussed. Then we discussed about the distance, displacement, speed, acceleration. I discussed about uniform acceleration, non-uniform acceleration and all, right? Now when you come for the synopsis 2, today we are discussing about the second synopsis, that is equations of motion. Okay, so there are 4 equations are there. I will explain one by one. This is the first equation you can see here. Equation of motion, first one you can see here. I will explain the next slide again neatly. Okay, when you come to the part of first equation, as I told, there are 4 equations are there. So which are showing the relationship between those terms which we discussed. Okay, the first one you see. So you can note down. First, I write the example, the heading as equations of motion. Right? Write down heading like this. First one is equation V is equal to U plus AT. Okay, this is the equation, first equation. So how we are getting this equation? First, what we have to do? We have to do some assumption. Let a body starts with an initial velocity. Initial velocity u, small u meter per second, and attains final velocity v meter per second in t seconds. So try to understand its consideration. What I consider is a body starts with the velocity of u, initial velocity is u meter per second, and then increase the velocity to v meter per second in t seconds. Then what is change in velocity? You can write change in velocity. So the velocity is changed from u to v. That is change in velocity is final minus initial. V minus u. Correct or not? It is from u, it is increased to v. Then final velocity minus initial velocity, change in velocity. Because time is also there. So you can write rate of change of velocity. Rate of change of velocity means how it is changes with time. That is v minus u by t. V minus u by t. But as per the definition, rate of change of velocity is nothing but acceleration a. Right? As per the definition, the rate of change of velocity is nothing but a. A is equal to v minus u by t. So a is equal to v minus u by t. How you got a? Because the definition, the rate of change of velocity is defined as a. So a is equal to v minus u by, bring t this side. So at is equal to v minus u. Bring minus u this side. So we get finally v is equal to u plus at or at plus u. That is equation 1. Got it or not? Just to derive the equation from the definition of acceleration. Please note down this. As it is, note down equation 1. Or you can make it as point number 1 here. Right? Make it fast. Okay. So note the equation 1 first, then we can move to the second equation. So let a body starts with an initial velocity u meter per second and attains final velocity v meter per second in t seconds. Then what happens? Change in velocity is nothing but v minus u. Rate of change of velocity is called v minus u by t. But rate of change of velocity is nothing but acceleration. So a is equal to v minus u by t. So by interchanging or by rearranging, you can get v is equal to u plus at. So it's named as, is known as, see, v is the final velocity, u is the initial velocity, a is the acceleration, t is the time. So this equation shows the relationship between velocity, acceleration, and time. When 3 quantities you know, fourth one you can find out easily. Right? By knowing the 3 quantities, you can find out the fourth one. Hope everybody. Right. So we are moving to the next one. We'll move to the second one, second equation of motion, right? So second equation of motion is about the distance. S is equal to ut plus half at square, right? Ut plus half at square. In general, we know the formula S is equal to distance is equal to velocity into time. Correct or not? Velocity is equal to distance by time. So distance is equal to velocity into time. But we have two velocities here. One is initial velocity, other one is final velocity. So what you can write S is equal to average velocity into time. So what is the average? You know everybody. You are doing for marks also. S is equal to V plus U by 2. Because two velocities are there, you have to find average. Average of 2 is nothing but sum of them into by product number into time is t. So S is equal to V plus U by 2 into t. So S is equal to, in place of V, we can write first equation of motion. V is equal to U plus AT plus again U is there. U by 2 into t. Bracket you can write since V is equal to U plus AT from equation 1. Okay. Now we can get S is equal to, see U is there, U is there. You can write 2U. 2U plus AT by over by 2. Right? Correct or not? This you can write as separately 2U by 2 plus AT by 2. I separated. So here 2 cancel. Right? Therefore, S is equal to, sorry, into T is there, na? Into T, overall T is there. So T. So is equal to U into T, UT plus AT into T, AT square, already 1 by 2 is there. 1 by 2 AT square. See, U plus AT by 2 into T is there. U into T, UT, AT into T, AT square. So by 2 is as it is, 1 by 2. So we got S is equal to equation for distance. UT plus 1 by 2 AT square. A simple way you got it from the definition of speed on distance only. So distance is nothing but velocity into time. But as there are two velocities are there in our assumption, that is same. Let us consider the body starts with initial velocity u. That is common for everything, every equation. So as there are two velocities are there, we have taken the average velocity into time. Average velocity is equal to v plus u by 2 into time. But v is equal to u plus at from equation 1. So I wrote there. So finally we got S is equal to ut plus 1 by 2 at square. Please make it note this one fast. This is helpful for you in regular also. Regular, when they ask for the derivation, we can do this method. So equation of motion number 3. After 2, we have discussed about 3 and 4 also. Here is missed. Right. Hope you are done with the second equation. Now we'll move to the equation 3. What? Equation 3. Right. What is third equation? V square minus U square is equal to 2AS. 2AS. So this is also similar. We can obtain from same. S is equal to average velocity into time is one equation. Say equation 1. And second one, A is equal to V minus U by T. From here you can write T is equal to. You take move T this side and A this side. So you get T is equal to V minus U by A. From these two, we can get the third equation. Because we know in place of T here, we can write this. Therefore, S is equal to V plus U by 2 average velocity into time. In place of time, you are writing V minus U by A. Yes, got it or not? So S is equal to what we get? Combined V plus U, V minus U by 2 into A, 2A by 2A. But what is this A? That's the form of A square minus B square is equal to A plus B into A as per your algebra. So you can write it as V square minus U square by 2A. Take 2A this side. Therefore, V square minus U square is equal to 2AS. That is equation number 3 of the equations of motion. Right? It also shows the relation between velocity, acceleration, and distance. So when you are selecting a formula, you have to see what is the data given, what you have to find out. Based on that, you can select either 1, 2, or third equation. Right? So not only third equation also. right? So finally, there is one more equation is there, which is very important for the high school level, now college level. The equation when you want to find the time at particular time, a particular second, the formula is Sn is equal to U plus A into N minus 1 by 2. Equation 4. Suppose, example I am telling, a body starts from here and moves from here up to here. So this is the total Sn we thought in n seconds. Time is n second. So suppose it travels for 1, 2, 3, 5 divisions. He asked to find out what is the time in the fourth, fifth second. What is this is nth second, you can say nth. What is the distance traveled in the nth, fifth second? Fifth means between this and this. Total 5 seconds you can calculate by S is into is total 5. But a particular time if you ask, fifth second, then you can use this formula. So this formula also can be obtained from that only. S is equal to, in place of S, you can write Sn is equal to Un. In place of T, I am writing N of An square. Say that is S1, you can see S1, equation 1. That is, this is for total n seconds. Total is n seconds. So maybe 5 seconds, whatever it may be. Suppose you want to find particular second is n minus 1, you want to find out. So U into n minus 1, that is that minus previous one. We'll get the particular second. Half A into n minus 1 whole square. Sorry, just a minute. Half n minus 1 whole square. So first one is in place of T, I have kept n. That is nth second. And that before that second you have kept. So this second to before that, if minus, you get the a particular seconds. So Sn is equal to S1 minus S2. We do from last to before one minus, we'll do that particular time. So S1 is given by Un plus half 1 by 2 An square minus Un minus 1 plus 1 by 2 A n minus 1 whole square. By opening the brackets, you can calculate this one, right? So open the brackets, U into n, Un will get cancelled. After all calculations, we'll get Sn is equal to same U plus A into n minus 1 by 2. By expanding this, you can expand the given addition and you can do the calculation directly. You can left with the this one. Because you see here, U plus 1 by A into as it is, right? Minus into U, minus U. U, if I can open this, U into n, Un minus U, right? Plus half, this is A plus B, A minus B whole square, you can expand. And after expansion, you get finally, after cancelling the things, you can get the Sn is equal to U plus A into n minus 1 by 2, which is the fourth equation of motion, which is used for a particular second. A body covers a distance of 5 kilometers in 5 seconds. Example. What is the distance starting the fifth second? What is meant by fifth second? Between fourth and fifth. Means first you are at fifth, then fourth, fifth minus fourth will give that particular second. Same thing we have done here. Okay. This is the fourth equation of motion. So all these are the, when bodies in motion will come across the different terms, and relation with the terms is given by equations of motion, which is the most important in the physics. These equations can be used not only in the kinematics or dynamics or anything, they are also used in the heat, thermodynamics, electricity. Everywhere we come across the use of these particular 4 equations. First 3 are most important. Of course, the fourth one also can be used for a particular second. So with this, we completed the second synopsis, equation of motion. So in next class, we'll discuss about some numericals related to the equations. Okay. But the reminder for you, the test 4 is a monthly examination, which is supposed to be conducted last Monday of the month, is on 28th October, where this time we have the cumulative syllabus. Whatever the syllabus we covered, 3 chapters. For example, units and dimensions, vectors, and kinematics. All the 3 chapters questions will appear. So prepare for all the 3 chapters. Recall I given the task for you, 3 tasks also given. We review them or go through the material. All the 3 chapters syllabus will appear for exam. Okay, same exam pattern. There is no length, same questions, everything is same, but syllabus is 3 chapters. Right? So that's all for today. You can see the homework is same only. You can write about the equations of motion. Okay. Explain the equations of motion, all the 3 mentioned, and take the signature from your subject teacher as well as from parents. Maintain the notes properly. Right? So that's all for today. Thank you, all of you. Have a wonderful day. Thank you.